exact triangles. There are two exact triangles. So the first one is pi on 3, pi on 6, 90 degrees. So the square root of 3, 1, and the other one is pi on 4, pi on 4 radians, 90 degrees. So 1 root 2. So we have an easy way to remember is so ka tova. So means sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, tan theta equals opposite over adjacent. So for example, if you want to calculate the value of sine pi on 3, so you would be standing at pi on 3, which is here, which is opposite root 3 hypotenuse 2. Therefore sine pi on 3, which is opposite over hypotenuse, which is square root of 3 on 2. Similarly, if you want to do tan pi on 4, which is you would use the other triangle, pi on 4, pi on 4, 90. And we already explained 1 root 2. So because you're trying to calculate tan pi on 4, you're right here, which is opposite and this is adjacent. So tan pi on 4 equals opposite over adjacent. So tan pi on 4 is 1 over 1, which is 1 from exact triangles. Now let's look at symmetry using unit circles. So we got two unit circles. The first one is anti-clockwise, which is going this way. So it's a 0, pi on 2, pi radians, 3 pi on 2, 2 pi. The other one is going clockwise, which is this way. So the angles would be negative, starting from 0, minus pi on 2, minus pi, minus 3 pi on 2, minus 2 pi. The quadrants remain same irrespective of clockwise or anti-clockwise. Quadrant 1, quadrant 2, quadrant 3 and quadrant 4, which would be same without any change. Then we use acronym called all stations to central. That won't change as well in clockwise as well. What that means is if an angle fell in second quadrant, here only sign is positive and remaining all are negatives. Then let's talk about the conditions in each quadrant. So the condition in quadrant 2 is pi take base angle. Condition quadrant 3 is pi plus base angle. Quadrant 4 is 2 pi minus base angle. But if you look at clockwise, it would be different. So in the quadrant 4, it would be minus base angle, minus pi plus base angle, minus pi minus base angle, minus 2 pi plus base angle. So normally the base angles are, as we looked in the exact triangles, so base angles are pi on 6, pi on 4, pi on 3. So these are the three base angles which you use in different quadrants in order to calculate the angles using symmetry. For example, if you would like to calculate exact value of cos 5 pi on 3, so that's the problem. So using symmetry without graphics calculator, how are we going to calculate value of that? Which I'm going to show you now. So because it's cos 5 pi on 3, because it is positive, you would be looking at anti-clockwise unit circle. So let's go unit circle anti-clockwise. So this is 0, this is pi on 2, pi, 3 pi on 2 and 2 pi. So first thing you would like to do is see where 5 pi on 3 fits. As you can see, 5 pi on 3 fits in fourth quadrant over here, quadrant 4. 5 pi on 3. As I explained before, quadrant 4 anti-clockwise, the condition is 2 pi minus base angle. So we need to pick a base angle in such a way that when you take from 2 pi, you should get 5 pi on 3, which is pi on 3. So it's 2 pi take pi on 3. So 2 pi take pi on 3 is 5 pi on 3. As soon as you do that, so as soon as you do cos 2 pi minus pi on 3, by means of symmetry, the 2 pi is gone, which becomes cos pi on 3. And the next important step is, because the 5 pi on 3 fits in quadrant 4, in quadrant 4 cos is positive, so you would put positive. Then using exact triangles, so as I explained before, if you look at the exact triangle pi on 3, pi on 6 and 90, pretend you are standing right here. So cos pi on 3 is adjacent over hypotenuse. Adjacent is 1 and hypotenuse is 2. So 1 over 2. So that gives you 1 over 2. Hence, without a graphics calculator, the exact value of cos 5 pi on 3 is half. So let's look at another example using symmetry, how to find the exact value of 7 pi on 6. So question number 2, determine the exact value of sine 7 pi on 6. So it's the same process. First, because it's positive, you draw your anti-clockwise unit circle. So anti-clockwise, quickly I'm going to fill the unit circle, 0, 90, 180 or pi radians, 3 pi on 2 radians and 2 pi. Then same scenario, quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Looking at the problem, sine 7 pi on 6. So if you look at 7 pi on 6, it actually fits in the third quadrant. 7 pi on 6. So the condition in quadrant 3 is sine, the condition is pi plus base angle. Then as I said, the base angles are pi on 6, pi on 4, pi on 3. out of these three base angles, pick a base angle. When you add that to pi, you should get 7 pi on 6. The only base angle that would give you that is pi on 6. So you would write sine pi plus pi on 6. And the next step is, if you look at it, 7 pi on 6 is in third quadrant, and in third quadrant, as per all stations to central, only tan is positive. So therefore sine becomes negative. So minus sine, because you're using symmetry, the pi is left out and it is minus sine pi on 6. Now again, draw the exact triangle, which is pi on 3, pi on 6 and 90 degrees. So this is root 3, 2 and 1. Now because we want to find value of sine pi on 6, that means you're actually standing here. And as I explained before, sine is opposite over hypotenuse. So this is your opposite if you are standing there, and this is your hypotenuse. So it becomes 1 over 2. So which becomes minus half. Therefore, exact value of sine 7 pi on 6 is minus half without the graphics calculator.